Welcome back to the deep dive. Today we are really getting under the hood, looking at the actual gears and levers of basic programming.
That's right. If you started reading up on how to write logic, you realize pretty fast it's more than just learning commands.
It's like learning a language. You need the grammar first. So today we're doing a deep dive into data, variables, expressions, and standard input and output.
And our mission here is really to pull out those essential, non-negotiable building blocks. The ones that when you misunderstand them, they lead to the most frustrating bugs.
Absolutely.
So the goal for you, listening, isn't just a list of definitions. It's about getting a really solid, quick understanding of the core parts that let a program work with data and talk to a user.
Especially focusing on how Python handles these concepts, because it can be a little surprising sometimes.
Exactly. We'll cover everything from how values are classified all the way up to the structure of an algorithm, which is basically the recipe for solving a problem with code.
Okay, let's unpack that. But maybe instead of starting with what is a value, let's jump straight to the implication. We know data is the lifeblood of any program, but the second that data gets into the machine, it has to be categorized.
That categorization is everything. The computer has to know what it's dealing with to store it, to handle it efficiently.
And this is where data types become so critical.
Right. And Python at its core really leans on a few major types. And understanding the difference, for example, between the two number types it's fundamental.
It really is. The core insight there is all about precision. Python splits numbers into the integer, that's your whole numbers, like 10 or, say, -50.
And then you have the float.
The float, right. Real numbers with decimal precision, like 3.14 or 99.99. And if you mix those up or treat them like they're the same thing.
That's a quick way to get some really subtle, costly errors down the line in your programs.
It is. And then the third major type, the string or string, that's just all the text we see.
Any collection of characters, really, usually wrapped in single or double quotes. And that strict separation between numbers you can do math with and text, you can't. That's the very first conceptual barrier you have to get over.
And we can't forget the unsung hero here, the Boolean type.
Oh, absolutely.
Just two states, true or false. This binary type is what makes every single decision, every bit of flow control and programming even possible. It's the gatekeeper.
It is. So once we have these values all nicely categorized, we need a way to hold on to them, a way to reference them over and over without rewriting the value every single time.
And that is the job of a variable.
Exactly.
Variables are just the labels we stick on our data. They give a human-readable name to a value. But unlike in human language where we can just make up words, the rules for naming these things are surprisingly rigid.
Well, the machine needs that predictability. Variables are identifiers, and they have to follow strict rules. They can't be a reserved Python keyword, for instance.
Okay, so no naming a variable if or for.
Right. And they have to start with a letter or an underscore. They can't have symbols like a $ or a %sign. No white space. You can use digits, just not as the first character.
And these rules, they're not just arbitrary. They enforce a clarity and consistency that you absolutely need when you're building something complex.
For sure. And for style, the recommendation is usually to use underscores. That's called snake case or camel case for names with multiple words. It just makes things cleaner.
The key is just to pick one and be consistent.
But this is where we hit a major Python insight that our sources really emphasized: dynamic typing.
Ah, yes. So if the variable is just a label, Python is kind of unique because that label isn't permanently glued to the first type of value you give it.
Exactly. The adaptability there is fascinating. The type of the variable is evaluated dynamically right when the assignment statement runs.
So you can start a program by setting, let's say, my data equal to the integer 10, and then just a few lines later, you can set that same my data to the string hello.
And Python just changes what it expects for that variable on the fly. It's an incredibly powerful feature that sets Python apart from a lot of other languages.
It offers flexibility.
A ton of flexibility, but it also means the programmer has to be really disciplined. Because if you're expecting a number, but you've accidentally put a string in there,
Python won't necessarily warn you.
not until it tries to do some illegal math later on and the whole thing crashes.
Right. Okay, so moving on from the data itself to how we actually use it, we need to draw a really sharp line between two core ideas: statements and expressions.
A statement is an instruction. It's something the Python interpreter can actually execute. It tells the computer to do something.
And we've already mentioned assignment statements, like setting a variable to a value.
Exactly. But this category also includes instructions for controlling the flow of the program, like if, for, or while statements.
I see the distinction, but when I'm looking at a complex line of code, how do I quickly know if I'm looking at an instruction versus a calculation? What's the functional definition of an expression?
An expression is a combination of things: values, variables, operators, function calls, that is designed to be evaluated.
Okay, so evaluated is the key word.
That's the key difference. An expression always yields a single result, a single value. A statement does something, an expression becomes something.
Got it. And a lot of statements like assignment, they depend on evaluating an expression first to get the value they need to do their job.
Precisely.
So if the expression is the brain doing its internal work, the next problem is getting that brain to, talk to the outside world and to take instructions.
Which brings us to input and output, or I/O. Standard output is how the program tells us its results. In Python, that's the simple universal print function.
So if you've evaluated an expression successfully, you use print to share that result with the user. Simple enough.
But controlling that output, that can be a bit of an art form. If you want things displayed neatly, you quickly run into what are called escape sequences.
Ah, yes, the backslash commands. These are special combinations that start with a backslash and they control formatting.
Right. The essential ones you'll see are N for a new line, T for a tab, and then using OR so you can actually display quotes inside a string without breaking it.
They're like the hidden tools for formatting your output perfectly.
They are. Now, standard input is the reverse. Getting data from the user, usually from the keyboard.
And this is where, every new programmer hits their first real wall.
It is the classic foundational mistake. Here is the critical point for you to remember. Any data you get from standard input will always, without exception, have the type string.
Even if the user types a perfect number.
Even if they type 4 or 5. Python doesn't see the number 45. It sees the characters 4 and 5. It's just text.
Which is why your program will crash if you immediately try to, say, multiply that input by 5. You can't multiply text.
Exactly. And the notes also pointed out that if a user types in multiple numbers on one line, separated by spaces,
you have to use the string's built-in split method to break that single text string into individual pieces.
Which leads us directly to our next topic, typecasting, or type conversion. Because the input is always a string, if you want to do any math, you must convert the data.
Thankfully, Python makes this pretty straightforward with some built-in functions. To convert something to a string, you just use string value.
And to go the other way, from a numeric string to an integer, you use int value.
And if you need that decimal precision, you wrap it in float value. This casting process is, it's absolutely essential for making user interaction work.
It is, and this flows right into computation. Now that we know how to get clean numeric data, we need the tools to actually manipulate it.
This is where operators come in, the special symbols and the operands, which are the values the operator acts on.
The standard set addition, plus, subtraction, multiplication, they're all pretty straightforward.
But the division operators,
Yeah.
that's where Python gives you some significant choices, and where you have to choose carefully.
Absolutely. You have what's called true division, which is just the single slash.
Yeah.
It always results in a float, so you get maximum precision.
But sometimes you don't care about the decimal part.
Right. Often in programming, you just want to know how many whole times one number fits into another. That's where you use integer division. The double slash just throws away the remainder.
And that remainder itself can be super useful, which is where the often overlooked tool, the modulus operator % comes in.
It is incredibly useful. It returns only what's left over after division, which is the key to so many cyclical or repetitive algorithms.
We also have the power operator, the double asterisk for exponentiation. But the real complexity comes in when you mix all of these operators together in one long expression.
Without a rigid structure for how to evaluate that, the answer would be totally inconsistent.
And that structure is the non-negotiable order of operations, which most of us remember as PEMDAS.
Right. It determines the precedence. From high to low, parentheses are always first, then exponentiation.
Then multiplication and division, which are done from left to right.
And finally, addition and subtraction, also left to right. Even a tiny slip in that order can completely change your program's outcome.
It's amazing how a single misplaced parenthesis can just break everything.
It is. And this brings up a great point about composition. The sources noted that simple operators like plus and get reused in surprising ways. They don't just work on numbers.
They also work on strings.
For concatenation and repetition, yeah. It just proves that Python really tries to have consistent, simple rules that you can reapply to different types of data.
So speaking of composition, let's tie all these little pieces, the values, variables, operators, into the big concept that guides the entire process, the algorithm.
An algorithm is really just the blueprint. It's the step-by-step process designed to solve a problem. If you need to calculate something, the algorithm is the ordered sequence of instructions you need to write.
And the practice of writing those steps, that's called composition. It's this idea of taking a big, complex challenge and breaking it down into smaller subproblems.
And then you incrementally build a solution by chaining together all those simple operations we just talked about.
Think about calculating something like the body mass index, or BMI. The formula is, what, mass in kilograms divided by the square of height in meters.
Right, and that's a real-world problem that immediately forces you to compose several of these tools. You need input from the user.
Then you have to cast that input from string to a number using int, or float.
Then you need the power operator, the k, to square the height. And finally, you need the division operator. It's a chain of simple steps.
Or take a classic exercise like finding the area and perimeter of a rectangle. You have to first define variables for length and width, read that data, cast it, and then apply the right expression. Every line depends on the one before it.
And for anyone who wants a real mental workout using just these basics, try to implement Heron's formula. It finds the area of a triangle if you only know the lengths of its three sides.
Ooh, that's a good one.
It's a multi-step calculation. It requires you to use intermediate variables to store a semi-perimeter calculation before you can even get to the final area. It's composition in action.
So we've covered a tremendous amount of ground here. We've gone from the microscopic level of data types all the way up to structuring a complex formula.
And you now have the essentials. Understanding values and types, how Python's dynamic typing can affect your code, how to handle that tricky string default input through casting.
And finally, how to structure the entire process into an algorithm.
The real value here isn't in just memorizing that pluses for addition. It's in understanding the constraints, the rules of naming, the strict order of operations, and then figuring out how to weave those few simple constraints into an elegant, effective solution.
The real challenge for any programmer isn't knowing the rules, it's figuring out how to combine them. I mean, you think about competitive programming problems like R2 or twosum.
Yeah, they're solved using nothing more than the tools we discussed today.
Exactly.
Yeah.
That tiny change like shifting a single parenthesis in a long expression, that's where all the power and, usually all the bugs
Right.
live. So now, what single thing will you try to calculate with these new tools?